Welcome to Ladyada.
Hey everybody, welcome to my desk. A beautiful Sunday to all of y'all. A lovely weekend, long weekend.
Yeah, we have a mini show and tell that I need you to do, Ladyada. On your desk is the latest 3D printed Ladyada and PT figurines from Noe and Pedro, and they did this with a tutorial that we have on learn.adafruit.com. But I want to show everyone the original ones that we got maybe 10 years ago from Doob in New York City.
I think it was more than 10
you
years.
walked into a.
Look at how skinny we were.
Well, you know what they say, the 3D scanner always adds like 10 pounds.
Actually, you're right. I'm a little chunky on this one.
Yeah.
Right, yeah.
But we weren't. Like we were doing magazines and stuff like what you were, and I was just along for the ride.
Okay, so this is us.
Anyways, that looks pretty good, right? That was like 10 years ago, 3D printed technology. And this is just, you type a prompt in and it looked at you and looked at me, and Pedro did a cool tutorial. So we do this every so often. We'll get ourselves scanned together. We have another one at the office. We have another one. I'm collecting these throughout the years as the technology's evolved. Yeah. So, there's folks that are like, oh, that one over there uses AI and everything. It's like, well, everything uses computers. You just don't like that weird computer.
This was cleaned up.
This was obviously done by something. Everything, it's not even AI that people are upset about. It's this other thing. Yeah. So that was made with a tutorial, and you can like have a prompt help you with the 3D model, watch our segment, rapid render. And this is a very wholesome thing you could do with your kids. And this super fun.
Okay.
Look at that. Cute little figures. Okay. We return you to your regularly scheduled program. That's our show and tell. I told folks that I'd show it off because we got them in the mail. Thank you, Pedro. Okay.
Okay.
What's
I don't
next?
want to break them because I'm.
No, I know.
Okay.
But yeah, our kid wanted. She's like tiny mommy daddy.
Yeah, I know. All right. So getting back after like a lot of tariff distractions. Tariff stuff's not done, but it's like I've got enough software.
No, the bleeding is still bleeding, but it's just we know where the wound is.
Yeah,
sort of.
So I'm able to work on some more hardware. So I'm getting some more prototypes out the door. So one thing I did, one thing I don't have. It's weird. I had all my prototypes with me, and then I put them down on the ground. Hold on.
Yeah.
So,
need a hand?
No, I don't.
You got them?
Yep. Okay, so this Ethernet breakout, it says Wiz 5100. It's actually the 55. This was just like, we had a couple of customers who were like, oh, I want to wire up the Ethernet Featherwing, but I don't like to like a Cutie Pie or an Itsy Bitsy or whatever. Like, yeah, that's like not easy. So I just made a little breakout. One thing I do is sometimes like once I have a really good schematic, it's like making it into different shapes. It's like I get a new product without having to do any firmware. So this was, I wired it up and it worked great. It has level shifting, which I kind of like because you can use this with an Arduino Uno or like one of the R4s, that just came out that's 5 volts or other 5-volt microcontrollers. So
I do like the idea of like a new chip comes out, actually like for chip companies like us because of this, but a new chip comes out and we put in on all the form factors that make sense, have the library's documentation. It's really neat because it's like, here's a feather form factor, here's a trinket, here's a Circuit Playground Express, here's, we have these like very specific things that people use in production systems and more, and you're able to quickly put it in a form factor. That's cool.
Okay, so that one got done. Another one that got wrapped up. So these are ones that are like the code's done, tested, and so we're going to get this into the shop. This is the ST Spin 220. So this is part of the family of stepper motor drivers. Like we did the A4988, and then we did the this is the TMC 2209. I don't know if it says that somewhere. Yeah, there it is, TMC 229. This is the prototype of that, the back silk. We got the back silk going. So this one, unlike the TMC has this cool like UART mode that it can do. There's also another chip later that came out that I do have a breakout for somewhere for like the TMC 2132 or something. And that has SPI, which I kind of like because it's a lot more microcontroller friendly than UART. But the ST Spin doesn't have, it's for low voltage. So it's good for like up to 10 volts. And, it's a much smaller chip. One thing that's kind of neat about it is it can do up to 256 microsteps. It can do like 1, 2, 4, 8, 16, 32, 64, 128, 256 by toggling the when you put it into reset and then you change the step and mode pins and then you take it out of reset. The thing is though, it's like the table for the mode pins to steps are like totally unintuitive. It's not like in logical order because it's like out of order. And so we actually decided to write a driver. And so I actually tried out Claude 4. So if you go to the computer, I can show off. This is just part of my history. So, I spent, let me see, like $13.
Can I ask you one question, Ladyada?
Yeah, sure.
So with Claude Code, this is, Claude doing automated things in the
Yeah.
terminal. And all the news is like, hey, we're seeing some neat things. Like it can do tasks. It goes away for 7 hours, come back, and here you go. So with all this happening and with every company coming out with their own, a very general overview, what's going on? Why is it able to do things in the terminal? Because they're saying Claude Code, but basically it's like terminal stuff. Why is it able to do that? Why is that new in the world of computing? And why is everyone freaking out about it? Because I think this is starting to get into.
I don't know why people are freaking. I mean, like
they're saying it's good. They're like, this is really good.
Yeah, I like it because basically, I use Notepad++. And Notepad++, as an editor, what I like about it is if Claude Code makes changes, it'll be like, oh, the file changed. I'm like going to sync it up. Whereas like other editors they don't like it when other things edit.
Oh.
You can also put it into. There's a mode called like tail mode. I don't know if I can, monitoring tail mode, where you don't edit it, you can just see the changes, which is nice because it's like there's the diff and then you want to look at the whole thing. What's interesting is now with the latest Claude Code, it will change models for you. So it started with Claude Sonnet 4, and what's interesting is it did some of like the bulk work. I think like reading the data sheet, it switched to Haiku because it's like, well, I'm just reading this data into the context. I don't need maybe to do as much work. And then it swapped over to Sonnet. And, whatever, I don't know, it kind of does it on its own. But, that's fine. I don't need it to, it could be that it can like get the, for the easy like PDF parsing where I'm like, okay, just read the data sheet and get the information out. It uses one model and then it swaps to another one. I also like it does this, let me see if I can find it. It does like little to-dos, which I like. It's like ding, 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 and it kind of goes through. And so I think I notice it's a new thing that Claude Code is doing. And what I like is it's able to, I'm telling it now, make the properties file. So it's not just coding. It's like make the properties file, git commit. It'll do commits for me now because I put the SSH key into like the GitHub key into my SSH, pub folder, whatever. I always check it, but it can do, commits within the folder, diffs, updates, changes. So I'm experimenting more with it. But I just kind of like it does all like it'll do Doxygen and like this I had to clang because I made some changes on my own, but it'll do like formatting stuff for me. So it's kind of like an ultra pre-commit as well as just writing the code itself. And like one thing that was really nice, I mean, like I could have written the code, but first off, it saved me a lot of time because, while it's thinking and working for a few minutes, I can do a couple of emails or I can like read through the data sheet. So I have the data sheet up on, this long window, which is kind of nice because it's like I have Claude here and then I have the data sheet. I scroll through it and I see like what's it doing. But then, like as I was writing the code, when I got to testing 256 microsteps, I'm like, oh shit, we're using ints, but we should be using int 32s. And like I told it to mimic the Arduino stepper library. So it read that documentation, but that library uses long and short and char. And I think it's like a curse. I really hate when people use int and long. I think like this is old C style, KNR. I love KNR. They're like wonderful people, but I think they kind of cursed us a little bit because int can change on each platform. Whereas I'm like, no, you should always use int 16T. Like I know exactly what type. And going through and I had to have it like update all the types because they start to overflow 256 microsteps. And that's the kind of thing that it's like a human can do it, but will miss one. But it did a very good job of just being very thorough.
Like we're in a different business. Like we do open source. So we want our things to work on every platform. So when there's opportunities like this to find code that we can have that works on every platform. I read this article and maybe I'll talk about it on Ask an Engineer, but someone said, oh, we called them the wrong thing. It's not AI or LLM. They're just weird computers because For the longest time, we did everything and computers were precise. It was a calculator and like 2 + 2 is 4. And now it like thinks about it and it's like, I don't know, let me check the sources. It does all these things and it asks questions and everything.
Mm-hmm.
And it's so hard to get something precise. So we have the opposite of what computers are, and we're just learning how to use them. Like it takes a lot of effort to make this work right. Where before a calculator is a calculator. So it's interesting like what you have to do. But once you get it going, it's a new way to use computers.
Yeah.
Good work.
Yeah. So, it was like, what's nice is that it took an hour and a couple hours for me because I was like doing other tasks, but it does it in the background. I don't have to use all my brain. All right, so go back to the overhead and I'll just show the breakout, which I've made a couple of small silkscreen changes. But
and this is helping you make more code, more hardware, because you don't have to like cut and paste for 14 hours in a row.
Right. So this is the ST spin breakout. So I just added labels for the step, backward, and forward LEDs because I like these LEDs. And it's just going through and it's doing every micro step iteration for me through the library. It's got the terminal blocks, the adjustable potentiometer, which does the right thing. Like you turn to the right, it turns up, and it's, it uses more current. It's very hard to test the current because the motor itself actually isn't a 1-amp motor. But I did, when I put it to the bottom, I measured the voltages and I kind of looked at the data sheet. And I think it's good. So that's going to be in the shop soon. So I ordered those. That's nice. And then I worked on a couple new designs. So going to the computer, I worked on this. This is like a common issue I have, especially dealing with LED nudes, some of which are 12 volts or 24 volts. And it's like, I'm like, oh, you need a 12-volt power supply. And it's like, you can get a boost converter, but it gets very complicated. And also then it's like, well, what resistor do I use if I have 12 volts and a 12-volt? Like, people can actually like really weird it out when it's like a 12-volt power supply and a 12-volt LED. And I'm like, use a choke resistor. They're like, I have no idea how to compute that because the value is 0. And I'm like, well, you pick like 100 or something. But it's that intuitiveness of a nonlinear voltage current relationship of like the device itself, which LEDs are, kind of weird people out. So I made this constant current booster, so you can give it 3 to 5 volts in, and then it's got this TPS 6169, which I've used for a couple of backlights, especially with like 5-inch and 7-inch displays. They actually have like 8 LEDs in a row to do the backlighting, and so you need like 24, 28 volts to power it. It's only 20 milliamps, but you need 24 volts. So that backlight driver, this isn't, the boostiest of boosters, but it can do, it has like a 1.5 amp switch. It's good for like, you can do 24 volts at maybe 100 milliamps or something. And then there's a little dip switch here that you can select. By default, it's 25 milliamps and then 50, 100. It's constant current, so it'll adjust to the output voltage. It's not like a normal booster where it's like 3 to 5 volts and you get USB 5 volts out, or 5 to 12 and it's like, okay, you can power a 12-volt device. This is constant current, so it'll always try to maintain that current up to 38 volts. So you have to be careful. You don't want to plug it into something that is not a constant current device, especially if it has a voltage limit, it'll blow it up. But for LEDs, it's great. So this will be good for strings of LEDs. If you have like a 12-volt nude and you're like, well, I just want to get that 12-volt 50 milliamps, 100 milliamps, or you have multiple LED filaments in a row, common request. So, this will break out. And then the last board I worked on was under development. It's under audio. Yeah, it's not radio. It should be under wireless, but it's under audio because the audio output is this SI74 3 breakout boards. So we have stocked the SI47, 47. Oh, sorry, it's discontinued. Yeah. So we had the 4713, which I really liked. It actually was an FM transmitter, which was neat because you could like make a little radio station. Unfortunately, this chip got discontinued and it got like super, super discontinued. So it's no longer available. I'm going to try to find another FM transmitter chip because I know that there must be one out there. But this family of chips, they have SI, this was Scilabs, but then they sold it to Skyworks. They actually made a bunch of other chips, including a lot of receivers. And then I started seeing this receiver chip appear in a lot of places, the SI4732. And this is kind of cool because it's AM, FM, shortwave, long wave, and I think it also can do single sideband if you do like a firmware update. 'Cause there's like an 8051 core inside. You can like upload new firmware, and someone like leaked a single sideband firmware for it. And it controls over I2C. You can do I2S output unless it's single sideband. I think you can do like for AM, FM, and maybe shortwave and longwave. Unclear. I added a digital crystal to it, and then I added this like headphone amp. Basically, the app note had a recommendation for a headphone amp, but it was like it wasn't a great one, and I wanted one that was a little cheaper, and so I found the LM4808. It's very generic, class AB, not super exciting. It does need a lot of components, but whatever. And then it's line out or stereo headphone out, breakout for all the I/O, level shifting for the 3-volt pins. Stemma QT, and then level shifting for the I2C, and then a power supply. But the part that was a challenge is this antenna section, because I wanted to support AM, FM, shortwave, and long wave, which is possible, but you kind of have to like piece together all these little bits. So how are we doing on time?
You're doing pretty good. You have exactly probably about 15 minutes left. So,
well, how much time has it been?
Oh, it's been about 15 minutes.
Great. All right, so let's go to the great search.
All righty.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada user-powered engineer and help you, yes, you find the things you want on digikey.com. Ladyada, what are you looking for this week?
Okay, so this week I'm working on a design using the SI4732, which is available at DigiKey. I'm not going to look for it because it's a part number that I know about, and so I don't need to. If you want other chips in that family, you can check them out. They're from Scilab Skyworks. And this is an AM/FM shortwave longwave receiver chip that's controlled over I2C, and it has an AM and FM antenna. And you can use an external antenna, or for AM you can use like a ferrite. For shortwave or longwave, you can use like one of those telescoping antennas that changes the capacitance. But one thing is, you can't go to my other monitor, so I'm going to drag this over.
Yeah.
If you go to the app note, not the data sheet, because the data sheet actually has like none of the stuff in it, but the app note for the 47 series, and they show all the family. So it's actually not in here. You're like, where is this 732? It's missing. It's actually the same as the 735, which is weird. But I don't know how, like they took the 735 and they just like made a new, the next version was a 732. I don't come up with the numbers. And you can follow with their instructions on how to do, the wiring. They tell you how to configure it. But the real big challenge is how to set up the antennas, because you want to have it be able to do, like I said, AM or FM. This is the headphone amp, which again, I kind of updated because it was mono and I was like, I want stereo. Let me find the 4.7 micro Henry. Okay. So the thing that was the challenging was I wanted to configure for the shortwave antenna, and they have a way for you to do either AM or FM or shortwave, and I think also long wave, using the 2 pins. So AMI and FMI are the 2 input pins. And this is the whip antenna, which is like they're missing an H. And there's a switch, and you can switch between AM mode or FM mode. So if you're using AM mode, you switch the switch down, and then you are connecting this ferrite antenna, this like, maybe you've seen it, it's like coils around a little bar. And that's the AM antenna for AM radio reception. But if you want to use it in shortwave mode, you flip the mechanical switch up, and then you're connecting this 4.7 microhenry inductor to your adjustable antenna, and then you can use the antenna to help you, tune to get the best config. So the only thing that's wacky is that you need to it's not wacky, but you need to kind of pick the right inductor. And they're like, well, you want the Coilcraft, I always look, because it's especially for like FM component, radio components, check what component they're telling you to use, because like they pick the right one. And if it works for you, just use it, right? Or at least you'll get good specs. Like they will tell you like the 33 picofarad capacitor for part of the filter that one needs to be C0G, which is a stability and frequency range. Like it tells you, like don't use, I mean, to be honest, every 33 picofarad is probably going to be C0G, but if you get to larger components like this one, they're telling you it's not that important. You can use an X7R, which is a much lower requirement. But then, for this other inductor, again, you need to use this part that they recommend, which I did. But let's look up this inductor, and you can see if I go to DigiKey, because I'm like, well, I know they carry Coilcraft. Actually doesn't show up. Now it's a little bit like, uh-oh. The data sheet isn't like terribly old. I will notice inductors. Yeah, this was made recently, 2025. But inductors, like they often like get updated and like they get improved, and then the part number changes slightly. So what I did is I searched for Coilcraft for the series, and I found the fixed inductors. And then I was like, well, I know it's going to be the 4.7 microhenry. So like I'll select that. And there's only 2 options, which was kind of nice. It's like, okay, I'm going to look at these. So they don't have the GLB, but they do have the XGRC. Again, like it's probably they changed like the temperature or stability, or like they improved something slightly with it. This is a marketplace product, so it's not stocked directly from DigiKey. It's sold directly from Coilcraft, which is fine. And they say the really important thing is minimal DC resistance and a Q of 20 or greater at 25 megahertz. That's basically like the resonance of the inductor. They're like, look, this is an important thing. You got to make sure that it's 20 at 25 megahertz or above. Okay, cool. And the self-resonant frequency is very high, which is good. I guess they like make sure it doesn't resonate in the frequencies that we're using, for like the megahertz, whatever, 88 megahertz is like FM radio, right? So maybe they need to be like above that. And then the size, 1008, which is a kind of standard size. It's surface mount. And then this is, I've seen these they have this cap. It's ceramic and it's wire wound. So it's good for, in this case, 260 milliamps. So this is not a bad inductor, and it's available, right? They have 10,000 sold from Coilcraft, takes 10 minutes or 4 days, $10 extra. Nothing wrong with it, but I did want to see if I could find an alternative, ideally one that's actively stocked by DigiKey, but also one that's maybe a little less expensive. Like this is like $1. That's a lot for an inductor that's like one component that's passive on this receiver board. So let's look for active wire wound 4.7 microhenry inductors. The DC resistance might change and the Q might change, but let's start with that and surface mount and see if we can get another inductor that has that same Q. Now, here's the thing that's a little annoying about Q is they don't always use the same test frequency. So like you could find one that's like close, and then also it's not like alphabetic, which is a little annoying. So there's like 16 at 25 megahertz. We actually want to be larger. We need to be 20. It doesn't actually look like there's one that would have a higher number. That's kind of like the highest it goes, 20 at 25 megahertz. So I'm just going to select that. Again, like you could go through others and look at the data sheets and like see what the Q is. But, to be honest, I don't want to spend a ton of time on this, and maybe I'll find something good enough. So another thing they say is, okay, so let's just take a look. Yeah, these all look about, right? They say, let's look at the notes again. They say minimal DC resistance, where the other one had 4 ohm resistance and a current rating of 260. These are all about the same. Let's look at normally stocking, and let's exclude marketplace. So let's look at ones that are actually available. And we got a couple options. There's actually, this is the Murata. It looks like they have just slight variations of the same LQW model. Looks like they have different cores. There's also one from TE. This TE one is actually like nearly identical. It's ceramic, wire round, 260 milliamp, unshielded, 4 ohm max. It's like basically kind of a clone of that Coilcraft. So if you wanted like the closest similar one, this would be fine. This is 39 cents each, 20 cents in quantity. But to be honest, if you're looking at the Murata series, and they have one that's air and then one that's non-magnetic. I don't know how much the coil actually matters. It might not matter at all, but non-magnetic and ceramic are basically the same. All other specs are identical: test frequency, surface mount size, etc., current capability. And so even though I don't know what's up with this air one, the price change here is only like 2 cents difference, 1.5 cents difference, but it is half the price of the TE one. So I'm going to go with this one, which they have in stock. It like looks similar. It's got that blue cap on the top. Same size, 1008, 4 ohm, 260 milliamp, 4.7 microhenry unshielded wire round with that Q of over 20 or more. So I'm going to pick this LQW2. So now I just saved like 70 cents on my bill of material, which means it's going to cost $2 less at the end. So it's more like looking at each item on your bill of material, even that inductor, you can save a lot of money and make a really good product within specs at a good price.
And that is Ladyada's Great Search Pick of the Week.
Where in the world is that part I need? The Great Search with DigiKey.
Okay.
All right.
We did a lot. We talked about inductors,
AI.
AI.
Yeah, I have a couple questions
3D
for you real
print.
fast.
Ask
I have a couple questions for you.
Questions. This is
So,
beautiful.
what? Yeah, we're doing great on time, too. So, looking at how you use things,
Yes.
it's always what's about to happen for everybody else.
Yeah. Because I'm lazy.
Well, I don't think so. I think you spend a lot of time to try not to do something, but you could probably just...
lazy in a good way. I want to.
if you had no ambitions, you wouldn't have to do all this work. So, with your use of using Claude,
Yeah.
and you being able to see what Claude changed, do you think that's going to be a new feature that's kind of like really blown up soon? Like editors, like it's so important now to know all the stuff that quote AI copilots are changing, like when it goes off and does its thing.
I think actually the next generation, the next important thing that's going to happen, because this bugs me, which means it bugs a lot of people, is once in a while. Okay, so first off, every single editor has different and like way of talking to AI has a different way of doing returns, and I know that they don't parse returns, but I parse returns, right? So having like sometimes it's / return, whatever return, but being able to attach the chat and the diffs, like kind of like Git. You know how it's a Git, you have the GIFs, Git and the commit log and the history, so you can see like what happened. I would really, and we had that a little bit with ChatGPT, where you could I could get a URL for the log history.
Yeah.
Now, to be honest, with Claude, I could like copy and paste it, but the problem is like my terminal eventually does run out of space. I would really love it if I could say like, look, save this log this conversation to like a
text file,
like a markdown text file. So it's like you could look through it, and I can and it's in like a .claude file. Right? So
could you maybe do that automatically? So I gotta say, let me just, for all the Claude fans, I use a lot of custom GPTs.
Yeah.
And I have all this it's actually starting to look like a program. I have this like initialization. I'm like, okay,
yeah.
If you're just doing grammar for me, lowercase is cool.
Yeah. The init file, I don't, yeah. I mean, I haven't spent a lot of time.
Yeah, you might be able to say like, hey, log everything to a text file as we're doing it.
Yeah.
Okay, well, that was my my question about this, because I feel like IDs are going to change now.
Yeah.
Because this is a new thing that we're not used to.
Yeah.
And it's like, what did you do while I was asleep? It's a what did you do while I was asleep view.
Yeah.
Okay.
Okay.
All right, that's our show, everybody.
Okay.
Finishing up exactly
Thanks.
on time.
I know. We did a lot.
See everybody during the week and more.
Have a great long weekend, everybody.
Have a fantastic weekend, and thanks to all the veterans, many people who did many things to make our lives possible in this type of society where Ladyada can share her engineering and code with all of you. So
there's a lot of countries that couldn't do this, so I'm glad I live one of them.
Thanks, vets.
Bye. Thank you, everybody.